today you've heard an awful lot about containers. You might feel a little bit like you've been beaten around the head with containers, and I'm only going to continue that by talking about them again. My background is I'm CTO of Microscaling Systems, and I've been in the business for a long time, worked in a lot of different areas, been CTO of several companies, and worked on quite a lot of systems, back-end systems servers as well for a very long time. And the reason why I'm going to be talking to you about containers, and the reason why I think everybody's been talking about containers today, is that paired with microservices and paired with orchestrators as well, there's an incredible amount of power that you can get, which can potentially completely revolutionize the way that you run your data center, the way that you architect your systems. There is an enormous amount of power. It's quite futuristic. It's not there immediately, but it is worth bearing in mind. This is one of the benefits that you get from moving to a microserviced architecture. So I'll talk a little bit about it. So one of the things that we've been kind of talking about today is who is going to be, what is the platform of the future? Who is going to be running on the bare metal in data centers in a year's time, in 2 years' time, in 5 years' time? Is it going to be, as Keith was saying earlier, is it going to be just bare metal, which is getting a bit of a comeback, but probably not? Is it VMs, which have been absolutely dominating the world for the past nearly 10 years now? Or is it containers, which seem to be, or at least apparently seem to be the new way of running your applications in production? And in order to think about that, I think it's quite helpful to step back and think about what are the benefits, what are the trade-offs for each of those particular types of technology. So let's go back and think about bare metal. Why do we not run on bare metal now? Why has bare metal been superseded by VMs? Because it's still underlyingly what we're running on. You've got the incredible power of actually running directly on the machine. But the reason why we stopped doing it, the reason why we went over to VMs. Oh, is that working? Is that? Thank you. The reason why we went over to VMs is that although they're incredibly powerful, they were quite inflexible. It's very difficult to scale up with a physical machine. You have to go out and buy new machines. You have to put it into your data center. There's all those downsides that we experienced 10 years ago when we were actually running our systems on bare metal, probably in our own data centers. They also led to incredibly poor server utilization, incredibly poor resource utilization, because you tended to put one thing on one machine. You didn't really share your resources very effectively when you were running on bare metal. So that's kind of what made us go off bare metal, although obviously we still run it underlyingly. So then came along VMs, and VMs seemed to solve all of the problems that bare metal had. Rather than being inflexible, they were remarkably and astonishingly flexible. They were completely agnostic about what you were running. You could run any operating system, any application on any hardware, on any host OS. The networking was phenomenally good. The security was phenomenally good. Their ability to divide up your resources and apply them to specific machines was astonishingly good. And they have been around a long time. They've really bedded in. And something I've realized about VMs, which is an advantage that when I first started thinking about this wasn't immediately apparent to me, but has become more apparent over time, is that VMs are a technology where all of the benefits of VMs accrued to the operations team. As far as the developers were concerned, it was transparent. I mean, it was an invisible technology. It was all about operations. It was all about how things were deployed, at least to start with. So all of the benefits accrued to operations. And all of the pain associated with learning about VMs also went to the operations team. And there was a lot of pain. Learning how to orchestrate VMs effectively was a lot of work. I mean, it took years and years to develop that expertise across the business, across any particular business and across the business in general. And VMs have got a lot, orchestration of VMs has got an awful lot better as time has progressed. But I think that's something that we quite often forget, that one of the reasons why VMs took off was because the gains and the pains all fell to the same team. And that's a much easier situation to manage than when the pains accrue to one team, but the gains accrue to a different team. So with VMs, that's an interesting, oh, what's happened there? There we go. Yes, it was in fact just the machine. So what's wrong with VMs? Is there anything wrong with VMs? Well, they are still slightly overweight. They're not perfect as a way of effectively utilizing the resources you have in your data center, because you're still running a full guest operating system on top of a full host operating system. So even that alone means that you've got an awful lot of overhead. They're also, although they're vastly, vastly faster than scaling up or scaling out when you're talking about physical machines, they're still not real-time scaling. It still takes a couple of minutes to bring a new VM online, even if you don't have to scale out your underlying physical infrastructure, which you do if you're running your own cloud, but you don't if you're in the public cloud. So there are huge advantages to VMs, but they don't necessarily solve everything. They still do have some disadvantages as far as operations are concerned. And then you've got containers, the new contender. And in many ways, they solve the weaknesses of both of the previous ways of running your applications. They are incredibly lightweight, because fundamentally a container is just a package of processes. It is just a way of getting your operating system to do some of the clever stuff that VMs do for you in terms of limiting what resources on a system are available to a particular process or set of processes. So they have some of the things that VMs do, but in a very, very lightweight way, with almost no overhead. So you get this is completely different from the advantages that we've all been talking about all day, which are amazingly good advantages, which are about deployment and packaging. Docker is fantastic, and it is an amazingly useful developer productivity tool, and all of the tooling and continuous delivery and continuous integration. That is a fantastic thing that containers can do for you, but it is not the only thing that containers can do for you, and it is not the reason why containers were invented. Now, when we're thinking about it, we tend to think that containers are a continuous delivery, a developer productivity tool, but they were actually invented around 10 years ago by people like Google and Sun as an operational tool to help massively cut down their operational costs, both in terms of the resource used and the amount of operational time that was required to look after systems. And I'll be talking about that through this talk today, but really what I want to say is containers are great, Docker is great, but they are not the only reason for using containers. It's not the reason why they were invented, and I don't think it's the way that will fundamentally change the world. And I think it's the operational use of containers that is really, really utterly groundbreaking. So, but they're not without their faults in a production environment. They are, the networking is still pretty poor, although we're getting better at that. And there are a couple of companies in London, actually, Project Calico and Weaveworks, who are working to get networking to scale up to meet the potential of containers, because you could be running millions of containers. You need new ways of managing your networks to handle that well. Security, obviously, that's always been a concern, a risk, a worry about containers in production, because VMs are so secure and they're so well bedded in, and we are in an increasingly aggressive and unsecure world. We worry about putting in any kind of new operational technology that will not have been as hardened in the field as VMs now are. But it's so much a focus of everybody's interest in containers. Everybody's going container security mad. I think that this will not be a problem in the long run. So it's definitely worth worrying about it, but not worrying about it to such an extent that you don't move towards a containerized infrastructure in production in the long run. But as I said, Docker is great. That whole way of packaging, the whole way of packaging applications so they can be moved easily from place to place, continuous delivery, all absolutely fantastic. And I'm not going to slag off Docker, because we wouldn't be here talking about containers if they hadn't popularized it and given you a value to containers right now without having to go through any pain or learn any new techniques. So Docker is fantastic, but for me, the really incredibly interesting thing about containers is how lightweight they are and how quickly they instantiate compared to any technology that is similar to them. So if we say that VMs are similar to containers in that they kind of assign a certain amount of resource to a particular application, then a VM will do that, but it'll take minutes. A container will do that, but it'll take seconds. And that's quite a game changer. And why is it a game changer? Well, let's talk first about something that Google uses for. They use this for throwing away the idea of autoscaling. So autoscaling, obviously, is bringing in additional resource into your data center to cope with, for example, increasing demand. The good thing about autoscaling, well, it used to be incredibly hard. If you ran your own data center, autoscaling was difficult. You had to plan it 6 months in advance. You had to bring in additional machines. You had to get the power for those machines. There were loads and loads, so it was a bit of a headache, so you never really wanted to do it, or you planned it a very long time in advance. With one of the huge advantages of the cloud is the ability to autoscale really quite quickly. So you can autoscale in minutes, you can scale in minutes, which means you can effectively autoscale. But that's still not real time. And it slightly lulls us into a false sense of security because you still have to plan in advance. You can't respond in real time to a peak an unexpected peak, an unexpected demand that falls on your systems. So, but with containers, actually, there is the possibility of responding to things in real time. It's not auto-scaling, because in order to auto-scale, you still have to add in additional resource, and that is never real time. Right now, it's not real time. It's not a real-time operation. But you can potentially reuse your existing resources in real time using containers. So, for example, imagine you were a video hosting service. You were, Kittens R Us, and you were hosting incredibly cute kitten videos, and you offered 2 services to your customers. You both showed them kitten videos, and that was a very, very demand-dependent operation. If people came to your site, they wanted to see a kitten video, they wanted to see the kitten video right now. You also offered kitten video uploading, so they could upload their own videos, which is a very expensive operation. But actually, that's less time sensitive for your visitors. If it takes a minute to upload a video, that's great. If it takes an hour, well, that's not the end of the world. So actually, you've got 2 services there. One is incredibly important and time critical, and one is important but not time critical. What Google came up with was the idea that, well, hang on a minute, if we could switch off these non-time critical services in order to use all of our capacity for the time critical services in order to cope with the peak in demand, then we wouldn't necessarily need to autoscale at all, and we wouldn't need to predict that demand in advance. And that is the kind of way that people like Google, people like Netflix are actually using containers to make their systems more real-time and self-managing. And I think it's a really interesting concept. I think it's absolutely fascinating. It does require microservices, and this is where my talk isn't completely divorced from microservices. You have to have a microservices approach in order to do this. Because if you just have a monolith, if you had one monolith that was doing both the video serving and the video encoding, there's nothing to turn off. So you have to have at least 2 services, ideally more services than that, so that if you're going to reuse your existing resources in real time to handle demand. So it is microservices are utterly key. Also, a cattle not pets approach. I don't know if people are familiar with cattle not pets. It's the idea that you can turn a service on and off very, very quickly. And you don't have to spend 10 minutes carefully or hours or weeks carefully tidying it up before you can turn it off. Because if your service that you need to turn off in order to free up additional space takes 10 minutes to turn off, then you've got then you might as well have auto-scaled. You're not real time. So in order to take advantage of any of this kind of real-time reactiveness of a system, you have to both have microserviced and you have to have adopted a cattle not pets approach. But this is all very well, but is it actually true? This seems like a crazy thing. Google is saying they're doing it, Netflix is saying they're doing it, but is it really true? It relies on three things. It relies on microservices, and that seems quite plausibly true. I think we're all here and we believe that microservices are possible. Cattle not pets, again, that's not crazy talk. That is a common industry move towards a cattle not pets approach to how we manage services. But that kind of instantiation of containers within a second, that's not necessarily true or achievable. Just because Google are doing it doesn't mean that everybody can do it. Maybe they're using special orchestrators that are not available to us, or they're running on special hardware that isn't available to us. So there are lots of reasons to feel suspicious of anything that they're saying that they're doing in this area. Is it something that only they could do? So we went and took a look at this, because the only way to find out is to actually experiment. Now, is your, Cliff, is your volume on? I might need to turn your volume down if... It's
probably off.
Excellent, cool. So you should, yes. We don't believe in taking anybody's word for these things. So if we wanted to find out whether containers were instantiatable in seconds, the only way to do that was to actually find out. And so we built a tool which was a very simple scheduler that sits on top of a variety of different orchestrators, because we wanted to try it with various different orchestrators. And what we did was we said, okay, let's take the most simplified form of what we're proposing here, which is that there are two types of service. A high priority service, which is incredibly time critical, and a low priority service, maybe a batch service, something that we don't really mind how long that takes to run. The high priority service in blue and the low priority service in lilac up there. And we also just produce randomized simulated demand, which is the red line there. And we asked our scheduler to say, talk to the orchestrator and try and meet the demand whilst at the same time using all of the rest of your resources for your batch process. Is this possible? Is this even vaguely possible on standard servers, on standard infrastructure? So we built this and we ran it against ECS, the Elastic Container Service, the Amazon scheduler for containers. We ran it against Mesos, which is another Mesos Marathon, which is another popular Mesosphere scheduler. We ran it against Swarm, and we ran it against Kubernetes, and we ran it against just the Docker API directly. And we put it in terms of infrastructure. We tried it on bare metal, we tried it on EC2, and we tried it on Azure. And in every case, actually, it did more or less behave in exactly the same way. And we saw more or less the same performance on everyone as well. That, yes, it could keep up with a kind of plausibly real-time demand there. You see, that's a win. No, not, that's a win. So it's winning there. Just catching up there, that's a win. So it can plausibly, those orchestrators, those standard orchestrators, and that's pretty much all the standard orchestrators, and the standard physical infrastructure can keep up with changing which containers you have running on your infrastructure in plausible real time. So, and that is the basis of the idea of having infrastructure which is effectively self-managing, self-regulating, self-healing, depending on the demand that's currently coming into your system. There we go. So, as I say, Google and Netflix are doing this. And what are they really doing it for? Well, they're doing it because the kind of resource utilization that most of us get was not acceptable to these guys. So the average data center utilization worldwide is about 10-15%. which is pretty terrible, isn't it, really? And the move to VMs and the move to the cloud has actually made that worse rather than better. It's now very easy to over-provision. And really, we don't have an awful lot of choice. You either have to get if you're going to auto-scale, you either have to get your demand prediction utterly right, which we know is pretty much impossible, or you have to massively over-provision. So we over-provision to a factor of nearly 10, which is quite astonishing, really, isn't it? For these guys, that was too expensive. They couldn't possibly do that. So they needed to adopt a more reactive way of managing, which didn't always or very rarely involved auto-scaling, and instead involved reusing your existing capacity differently depending on your current demand profile, which we call microscaling for a change from that. And with that, Google have achieved around 65–70% resource utilization. That's versus 10 to 15% that we're achieving. Netflix around 50% because they use batch processes a little bit less heavily than Google do. But again, that's for 5 times what we achieve. And I think it was Keith mentioned earlier that it is not unrealistic to assume that you could double or treble your resource utilization by moving to a clever, orchestrated, containerized model. And that can make an enormous difference to your hosting costs and also how your operational costs as well, how hard your system is to manage. So it's something that's well worth achieving, I think. So what is it? What is the throne? What are we all fighting for here? Well, I think in terms of ops, we're fighting for lower costs with higher server densities, lower maintenance, more self-healing, more reactive systems that will manage and look after themselves without you having to constantly anticipate demand that might not be anticipatable. So that's everything that there is to be gained from considering containers as an operational technology as opposed to purely a deployment or a development technology. Was that my buzzer from my time going? Oh, wasn't? Okay. Well, in that case, I have pretty much finished. My last slide was in summary. I talked at the beginning about how there was a battle for who was going to win, who was going to be on the bare metal in the data centers in 5 years' time. But actually, that battle has already been fought. I hadn't realized this at all, but that battle has already been fought by people like Google and Netflix, who looked at VMs and looked at containers and said, well, only containers can deliver the kind of performance and the kind of self-healing, the kind of resource usage that we need. So although we might think that there is a battle to be won, actually, containers has kind of already won it. We will get there eventually. I have no doubt about that, because it does deliver low maintenance and lower costs. Operationally, what is required for you to get there? Well, you've got to containerize, but there's been a lot of talk about that earlier. You've also got to, you've really got to put an orchestrator in. And that is quite painful. So you do need to have a vision for what that's going to deliver for you. There are some absolutely excellent orchestrators out there: Mesos, Kubernetes, Swarm, ECS. They're all very good. They're in a decent state for you to at least be playing with, at least be starting to think about them. Because microservices that are containerized and orchestrated is really a different world for the data center. And it's a world that's well worth moving towards, I believe. Yes, there we go. Containers are coming. I think there's no doubt about that after what you've heard today. It matches so well with microservices. So, and that's me, I think.